Now we're going to be naming esters. Here is your functional group for esters. In esters, let's look at what is the way that we do it, like prefix, suffix. But here I want you to see what is, say, the analogy in naming esters, in naming carboxylates. So naming salts of carboxylic acid. In the example here that I have, let's say, if I draw this is acetic acid. And this is the conjugate base. So if this react, for example, with sodium hydroxide, you're going to form sodium acetate. So I'm going to say the word sodium first and then acetate. So, and we're going to be using the same idea. So for the esters. So let's write this down. Sodium acetate. And now if you said the ester above, what you're going to do is name what is attached to the oxygen first. So this, and that is a methyl. So when you name this ester, you're going to say first methyl, and then this is the acid part. So we also say that this is, say, the alcoholic portion, and that's my methyl. And this is the acid portion. So I have already identified what is attached to the O. So I say methyl, and then I'm going to say methyl acetate. So similar to this, methyl acetate. So we're going to be using the same idea. So ATE is your suffix. And remember that what is attached to the, say, alcoholic portion attached to the O, you're going to name that first. So let's go and do this one. So identify what is first attached to the, say, alcoholic portion. So attached to the O. What is that? That is an isopropyl. So I'm going to write that down. Isopropyl. And then this is the acidic part. So we're going to do the numbers. So this is my carbon number 1. Remember the one in the carbonyl of the carboxylic acid derivatives. That's my number 1. This is 2. This is 3, 4, and 5. So, and remember that termination. So it's 5. So it is a penthanoate. So isopropyl is that substituent. It goes, not the substituent, but actually the alcoholic part, let's say. We'll say that first. But this is a penthanoate, but I need to say that I have 2 chlorine in position 3. So this is going to be the overall name. 3 isopropyl 3 comma 3 dichloro and penthanoate. Let's do this. Okay, what do we say? Dichloro. And then 5. So penthanoate. So again, we're keeping that termination, ATE. And again, what is attached to the O here, the alcoholic portion, is an isopropyl. And the rest is identifying substituents. So 3,3-dichloropenthanoate. Okay, so now, here I don't need a dash. All right, let's do, well, this is, say, easier because we know what this is coming from, benzoic acid. So let's write down, remember that benzoic acid is this. And if I keep that substituent, well, this is going to be 3-bromobenzoic acid or meta-bromobenzoic acid. But now, naming the ester, what do we need to do first? I need to identify this. So that's the first thing that I'm going to be writing. I'm going to write it down here. So that name is going to be methyl first. And then it is a benzoate. So I'm going to replace, it's not benzoic acid, it's a benzoate. So, and it's going to be 3-bromo benzoate. Again, that termination had changed from benzoic acid. It was OIC, right? Benzoic acid. This is 3-bromo or meta-bromo. We can also use the N here. But again, strategy-wise, it's the same. What is the alcoholic part first, and then you add the rest of the name. Okay, now, doing this one over here, let's erase something so that I have room to write that name. And what are we seeing here? Okay. And let's see. Again, thinking, what is the acid it come from? The corresponding acid, if we had an acid that was a cyclohexane and then this will be cyclohexane carboxylic acid. Now, this is cyclohexane carboxylate. But now I need to say, first, identify my ester. I need to identify what is this, because that's before. So this is, it has 4 carbons, so it's butyl. So butyl, running out of ink. Butyl. So that's that. And then that will be my carbon number 1. Now the question is, do I number going down here and put the number 2 for the metal, or to this side? Because it's identical, I'm going to assign that priority alphabetically. So ethyl goes before methyl. So I'm going to say this is carbon number 2 in the ring, 3, 4, 5, and this is 6. Now I have that. This is butyl, and then I'm going to say 2 ethyl, 6 methyl. So 2 ethyl, 6 methyl. Again, this is listing alphabetically. And this is cyclohexane carboxylate. Carboxylate. Okay. This is this one, and now I'm gonna erase this and do our last example. And for this one, I also need to specify the ring as my parent chain. But what is this? It's a cyclopentane. And so it's going to be cyclopentane and carboxylate. But first I need to say what the alcoholic portion. So that name is going to start with ethyl. So ethyl, and then cyclopentane, but where is the alkene? So 1, 2, and 3. So 3 cyclopentane, because it is an alkene. And then carboxylate. So strategy was the same. If I had the carboxylic acid, let's draw it like that. The parent carboxylic acid will be 1, 2, and 3. So this is 3 cyclopentane carboxylic acid. And now what I did is I listed the ethyl first, so ethyl, and then cyclopentane carboxylate. It's no longer a carboxylic acid. All right, so we're going to continue naming others functional groups in the family of carboxylic acid and derivatives.